Hi, and welcome to Bits of Java. We're going to learn about decimal and binary numbering systems. So let's start off with the decimal system, which you should be familiar with. So the decimal numbering system is base 10. So let's do a little review. Let's say we have the number 742. If you think back to like elementary school or middle school, you would rewrite this as I have 7 hundreds plus 4 tens plus 2 ones, and that gives you 700 plus 40 plus 2, which is 742. Very cool. So what does that mean? Let's think about the 7 and the 4 and the 2 for a moment. Think about your place value. This 2's place, this 2 right here, was the 1's place right there. This 4 is the 10's place, and the 7 is the hundreds. Well, those can be represented as powers of 10 because it is base 10. So this right here is 10 to the 0, 10 to the 1, and 10 squared. So that's how place value works for decimals. And in fact, if you actually had some sort of decimals after this, if it was like 0.34 or something, then this would be 10 to the negative 1 and 10 to the negative 2. Now, what happens if we want to work with the binary numbering system? So in binary, move down another line, here we go. So in binary, it is base 2. So what does that mean? In decimal, we have the values of 0 to 9 available to us. Binary, we only have zeros and ones. So let's take a number in binary. Let's say it's like 1110. Well, what does that mean? So we have, just like before, let's take a look at, instead of 10 to the 0, it's base 2. So it's 2 to the 0, and 2 to the 1, 2 to the 2, 2 to the 3. So if we were to write this out as a type of just expand it out, this is the 1's place, this is the 2's place, the 4's place, and the 8's place. So if we were to write this out in decimal, we have 1 8, so I'll just write an 8, plus we have 1 4, plus we have a 2, but we have no 1's. So 8 plus 4 plus 2, 12, 14. So 1110 in binary is 14 in decimal. Let's try a larger example. So let me clear this all out. Oops, there it is. Okay. So let's say we have a number 101101111. So let's think about how this works in binary. We've got 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Therefore, 1's place, 2's place, 4's, 8's, 16's, 32's, 64's, and 128's. These 8 digits here make up what we call 1 byte. So each binary digit is called a bit, and 8 binary digits, or 8 bits, is 1 byte. So in this 1 byte, if we were to calculate it out, we have 128 plus 32. There's no 64 plus 16. There are no 8's. There's a 4. There's a 2. And there's a 1. So if we add all that up, what does that equal? We've got 20 there plus 130, which is 2130, 150. And let's see here, the 32, 182, and a 1, so this should be 183. Last thing, let's go ahead and convert some decimal back to binary. So decimal back to binary. Let's say we have the number 50. Okay? So the number 50. We want to figure out, well, 128's not going to fit into 50. Neither is 64, but a 32 would. So right away, I've got no 128's, no 64's. I do have a 32. So now, well, 50 minus 32 is 18. So I've got 18 left over, and an 18, a 16 will fit into an 18, so I'll put a 1 there. So I'll subtract the 16, that gives me a 2. So a 2 is way down here, so I'm at 16, so I've got no 8's are going to fit. No 4's are going to fit. A 2 will fit, and I subtract the 2. I am left with nothing, so the last bit will be a 0. So I've got 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0. That's the number 50. Let's try one last one. Let's try the number 19. The number 19, well, 128, 64, those won't fit. A 16 will fit, so I've got 3 leading zeros. A 16 fits. And 19 minus the 16 is going to give us 3. So with 3 left over, I can have a 2 and a 1. So I've got no 8, no 4, but I'll have a 2 and a 1. So I'll have 0, 0, 2, 1. So that is how you translate from binary to decimal and decimal back to binary.